so far we've talked about 3 ways that you can solve systems of equations. You can graph the lines and see where they intersect. You can use the elimination method to eliminate a variable. And you can use the substitution method to substitute one equation into the other. And so you get to choose, if it just says solve this equation, if you need to solve an equation, you can choose which method you use. And so you need to know all 3, but if you get to pick, then you should pick the method that makes the most sense for that problem. So I just want to go through this a little bit. So you should have a graphic organizer that looks like this. If not, you can just draw it out on your own. And so these are the 3 methods. And so go and think about when would be the best time to graph it. When would be the best time to solve a system of equations by graphing? So one time you might want to solve it by graphing is what if they literally give you graphs? Like if they give you a graph and here's a line and here's a line, then the solution is right there where they intersect. So when you're given graphs, so use this when you have graphs. Or when it's easy to graph. For example, if you're given a couple equations that are both in y equals mx plus b format, slope-intercept form, those are pretty easy to graph, and so maybe you want to solve with graphing in that case. For substitution, go ahead and think about when it would be best to use substitution. So I would use substitution when one variable is by itself. So when one variable is by itself. For example, if you had this system of equations, notice that the y variable here is by itself, and so I could pretty easily substitute this in for that y, and so substitution would be pretty easy on that one. And then for elimination, I would use elimination when you could easily add the equations together and eliminate a variable. Well, let's write that down. And you can easily add the equations together to eliminate a variable. For example, if you had negative 4x minus 2y equals negative 12, and 4x plus 8y equals negative 24. You see how I could pretty easily, everything lines up, the x's, the y's, the constants, and I could add them up and very easily eliminate that x variable. So that's a good time to use elimination. But you get to pick. If you prefer one method over the other, feel free to use that method. And do remember, no matter which method you're using, if you ever get a false statement, something like 0 equals 4, which is not true, then that indicates the lines are parallel, they never intersect, so there's no solution. Also, if you ever get a true statement, but the variables are gone, something like 0 equals 0, which, sure, but it's not that exciting, that indicates the lines coincide. They're actually right on top of each other. So there are infinite solutions. The entire line is a solution. Okay.